Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to chemistry class with chapter 5 liquids. Today topic under discussion is liquid crystals. We will discuss its discovery, definition, its type, then difference between liquid and liquid crystals, how liquid and liquid crystal resembles with each other, difference between crystalline solids and liquid crystals, how crystalline solid resembles with liquid crystals, uses of liquid crystals in our daily life, and then assignment. Let us start our today's lecture. First of all, we will discuss discovery of liquid crystals. Polystyryl benzoate is an organic compound that is widely used in hair colors, makeup products, cosmetics, and LCDs. Polystyryl benzoate was first discovered in 1888 by Austrian botanist Friedrich Rienzi. He discovered that when crystals of polystyryl benzoate were heated at about 145 degrees centigrade, a cloudy solution appears, a turbid liquids appear. On further heating, up nearly around 179 degrees centigrade, the cloudy solution becomes a clear liquid. This intermediate phase between crystalline solid and clear liquid is known as liquid crystal. This liquid crystal is in between intermediate phase between crystalline solid and pure liquid form. This liquid crystal is intermediate phase and is unstable. When solid is heated, a turbid liquid is formed, which is known as liquid crystals, and on further heating liquid crystals, it is converted into pure liquid. If reverse process occurs, that is on cooling, a turbid liquid comes, that is liquid crystals are formed. On further cooling, crystals of polystyryl benzoate appears. That is on reverse reaction, again you get a turbid liquid. It means liquid crystals exist between two temperatures, melting temperature and clear temperature. It means liquid crystals are intermediate phase, that is they are semi-solids and exist between solid and liquid phase. We can define liquid crystal as intermediate phase having both solid and liquid property in between solid and liquid, and this intermediate has properties of both crystalline solid and true liquid. These are known as liquid crystals. That is, it is intermediate phase between solid and liquid, and this intermediate phase has properties of both crystalline solids and true liquid. Here is solid, and you can see it is orderly arranged. Then these are the liquid crystals. Molecules have a little bit orderly arrangement, and these are the liquid molecules. Types of liquid crystals. There are three types of liquid crystals: pneumatic, cymatic, and polystric. Pneumatic means thread-like. They are simplest form of liquid crystals with no orientation and no orderly position. They are commonly used in telescope to clear the image. Cymatic are soap-like. They have slippery, thick residue found at the bottom of soap dishes. They have orientation with orderly positions. Cymatic liquid crystals along with pneumatic liquid crystals are used in producing liquid display screens. These are cymatic liquid crystals and these are pneumatic liquid crystals. The last is polystric liquid crystals. Polystric liquid crystals are known as chiral pneumatic phase. This type of liquid crystals has characteristics of changing color when it is exposed to different temperatures. For this reason, polystric liquid crystals are used in thermometers. What is difference between liquid and liquid crystals? Pure liquids are stable, while liquid crystals are unstable intermediate form. They are non-isotropic, while liquid crystals are isotropic. Isotropic are the substances which show same properties in all directions. That is, their properties are not dependent upon directions. They show same properties in all directions. Pure liquids are present in random fashion, while in liquid crystals, molecules are long and rod-like. Pure liquids do not change their color with temperature change, while liquid crystals change their colors with temperature change. How liquid crystals resemble with pure liquid? They both can flow, they both show surface tension, and they both have viscosity. Now, what is the difference between crystalline solids and liquid crystals? Crystalline solids are pure stable form, while liquid crystals are unstable intermediate form. Crystalline solids have definite arrangement of ions and molecules. Liquid crystals are long and rod-like. Crystalline solids do not change their colors with temperature change. Liquid crystals change their colors with temperature change. Crystalline solids do not have viscosity or surface tension, while liquid crystals have viscosity and surface tension. Crystalline solids cannot flow, while liquid crystals can flow. They may be isotropic or anisotropic, while liquid crystals are isotropic in nature. How liquid crystals resemble with crystalline solids? They both have orderly arranged particles and both show optical activity. These are the properties that are related with light. Now, liquid crystals and our light. Liquid crystals are beautiful and mysterious. I am fond of them for both reasons. These are the words of P.G.D. Jennings. Liquid crystals are found in living organisms fundamentally. Like DNA and cell membranes have liquid crystal phases, our brains are around 70% liquid crystals, and liquid crystals are also found in muscles. The amazing iridescent colors of some insects and also slime are because of liquid crystals. These beautiful colors are because of liquid crystals. Now come towards uses of liquid crystals in our daily life. Here is overlook of liquid crystals in daily life. They are used as temperature sensors in thermometer. They are used to point the potential failure in electrical circuits, to locate blockage in veins, arteries, infectious and tumor by skin thermography, in display of electrical devices like the digital watches, calculators, and computers, as solvent in chromatography. First of all, we will discuss use of liquid crystals in temperature sensors. Like solid crystals, liquid crystals can also diffract light, that is, they show optical activity. When one of the wavelength of white light is reflected from liquid crystals, it appeared color. As a temperature change, the distance between the layers of the molecules of liquid crystals also change. Therefore, they reflect light changes accordingly. Because of this light change, they can use in temperature sensors. Temperature sensors are like liquid crystals change their color with change in temperature. They, the temperature sensors are used in liquid crystals thermometers. These liquid thermometers have very profound usage in measuring the skin thermometer of especially infants and babies. Liquid crystal thermometers use liquid crystals that change color to respond to the temperature change. In fact, Mixtures of liquid crystals are enclosed in separate partitions, and number on the partitions indicate temperatures accordingly according to the amount of heat present. That is, you can see 36, 38, 39, 40 and degree centigrade, and here is in Fahrenheit, that is 96, 98, 100, 102, and 104, and so on. When these thermometers are put on forehead, they show the temperature with these colors. Liquid crystals can be used in microelectronic circuits to point out the potential failure in microcircuits. A method for detection of failure in electronic devices having electrical circuits, liquid crystals can be used easily. Voltage is applied across the electrical circuit so that temperature of the liquid crystals at the point of the failure changes, and that change can be measured easily. Liquid crystals in medical field. Liquid crystals are used to locate veins, arteries, infectious and tumorous body parts. Actually, these body parts are warmer than the surrounding normal tissues. Specialists can use technique of skin thermography to detect the blockage in vein and arteries. When a layer of liquid crystals is painted on the surface of the body, a tumor or cancerous part have hot areas which is colored blue. So this technique can be used in early diagnosis of breast cancer. Medical diagnostic thermography. Use of liquid crystals in display of electrical devices. Because liquid crystals have color change ability, or they have colored, so this property can be used in electrical devices. Liquid crystals are used in display of electrical devices such as digital watches, calculators, and laptop computers, etc. These devices actually operate due to that temperature, pressure, and electromagnetic fields that affect weak bonds, which hold molecules of liquid crystals together. This can be used in this way. A liquid crystal layer is imparted, which create visual effect on the screen. Liquid crystal is a state of matter between solid and liquid. LCDs do not generate light by their own, but they rely on sunlight or room light to generate images with the help of liquid crystals. Actually, these liquid crystals are playing a role in the display of that electrical machines or that electrical appliances. These all have liquid crystals in display of their screens. The last uses of liquid crystals in chromatography. They are used in chromatography technique. In chromatographic separations, liquid crystals are used as solvent as well. The liquid crystals can be employed as the chromatographic stationary phase, having the ability to separate the component of mixtures which have different molecular structures, that is structural isomers, positional isomers, and optical isomers, etc. I hope you have enjoyed today's lecture. Here are some assignment questions for you people. Define liquid crystals with some examples. How liquid crystals resemble crystalline solids? How will you differentiate between liquid crystals and pure liquids? Liquid crystals can be used as temperature sensor. Comment on it. Liquid crystals found wide applications in medical field. Explain it. What will be the future of liquid crystals? Give your views. Thank you. I hope you have enjoyed the lecture. Thank you and have a nice day.